Our project applies dynamic competing risk survival analysis to limit order execution in financial markets. When you submit a limit order, you wait at a fixed price hoping to trade cheaply, earning the bid-ask spread. But this comes with a hidden risk called adverse selection. An informed trader can fill your order just before the price moves against you. That's a toxic fill, and it erases every cost advantage of passive execution. Prior work either predicts when an order fills using classical survival models or whether a fill is toxic, but never both jointly and never with real-time updates as the order book evolves. We address exactly that gap.
Our task is a joint competing risk survival problem, simultaneously predict the timing and the quality, favorable or toxic, of each order, and the prediction is updated at every order book snapshot. Our data set comes from data bento NASDAQ at TCH, covering 17 liquid stocks with various characteristics from October to December 2025. Roughly 62,000 limit orders per stock over 62 trading days. An order is labeled toxic if the mid price moves adversely beyond the half spread within a stock-specific horizon. On-field orders are treated as censored. This is an application of dynamic debate, originally developed by Lee for clinical longitudinal data to financial microstructure. We adapt the competing risk framework with two causes, favorable fields and toxic fields. For each cause, we estimate a cause-specific cumulative incidence function, discretized into 30 quantile-based time banks, output as a joint softmax that include a survival logic. Censored on-field orders are handled naturally without any specific casing.
Our proposed model is a member-augmented dynamic repeat. At each snapshot, the LOB history is encoded by a shared member state space model running in linear time, followed by attention pooling with a residual skip from the current snapshot. Two cost-specific MLP heads produce the joint output. Member selective state compression is critical here. Its fixed size recurrent state avoids the quadratic time reevaluation cost of transformers, making it well suited for real-time order management in high-frequency settings. We train with three-component loss, negative log likelihood over event time banks, a pairwise ranking loss on the cumulative incidence functions, and an auxiliary MSE for next step LOB prediction. Through ablation, we determined alpha equals to 8 and beta equals to 0.1 as optimal loss weights. We benchmark four encoder architectures sharing identical decoders, GRU transformer, a GRU transformer hybrid, and our proposed member. Three metrics evaluate performance: C index for temporal ranking, IBS for calibration, and precision recall AUC for toxic field detection. Under the severe class imbalance in this data, toxic rates range from 16% to 65% across stocks.
With completed final model so far, the results average across Apple, Intel, and Lucid test sets. GRU leads on C index at 0.735, the strongest temporal ordering, with transformer variance not far behind. But both GRU and transformer inflates their IBS to roughly 0.25, indicating miscalibrated probability distributions. Member achieved the highest PR-AUC at 0.532, the most practical relevant metric under class imbalance, with IBS nearly matching the uninformed baseline, confirming well-calibrated survival distributions. Members runs at approximately 2 milliseconds, 20% faster than GRU and 35% faster than transformer. This advantage holds consistently across all small batch sizes, which is realistic regimes for live order management. The call trade-off is clear. Lossless RNNs and transformers wins on temporal ranking. Members' selective compression wins on classification quality and deployment efficiency.
We present the first joint dynamic competing risk model for limit order books and the first application of member SSMs to both LOB modeling and competing risk survival analysis. For adverse selection monitoring, member is a preferred architecture. Highest PR-AUC, best calibrated probabilities, and lowest latency. For pure temporal ranking, GRU remains competitive. Open questions include the regime robustness under flash crashes, multi-asset shared representations, and whether members' recurrent states can achieve sub-microsecond latency on FPGA hardware. Here are the references for our work. Thank you.